Hello, Algebra students. We are going to take a look at the Exam 3 review. Exam is next week. I'm going to do a review now, which you can watch again and again, obviously, later on. And if you have questions, hopefully you will email those or ask me through comments or something. And I will include those. I can make another video and post. We can have another review on Thursday. We will have time to have another review Thursday next week. So we'll do 2 reviews to make sure that your Exam 3 grade is as high as possible, moving into Exam 4, moving to final, which is in 3 weeks. So I will switch here to our Exam 3 review page. Previous page showed you the dates and all of that stuff. Exam is going to be, I want to put exam on Canvas so that you don't have issues with connecting like last time. So we're going to have some changes, and we'll have that, and I will have to sort out Exam 2. Probably I will replace it with we'll see, the final exam, whatever is the higher grade, Exam 2 or a final, we'll figure it out. Right, I'll post that in announcements and we'll go from there. For Exam 2, because there was a lot of issues with connectivity, some of you did very well, some of you didn't do very well, and some of you couldn't connect at all. So it's just a whole bunch of problems. But for Exam 3, we're talking about chapters 5 and 6. And we're going to look, since it's the online exam, and it's going to be again 60 minutes, anywhere from 10 to 15 questions, whatever is enough to fill in 40 minutes of time to do it, plus 20 minutes to check, so 60 minutes. And then if there are accommodations, that will kick in, obviously, as I mentioned before. So 10 to 15 questions for 60 minutes online, and you will go on Canvas. And the dates are Friday. Let me just make sure that I have all of that correct. So Friday 4/24, Saturday 4/25, Sunday 4/26 ends at noon, which means, let me put us in red, must start before 11 a.m. If you are waiting to take the test in a last second, that last second is an hour before the test closes, because you have an hour for the test. If you start your exam at 11:50, you only have 10 minutes for the exam. So if you are leaving the exam for the last second, then you have to take it, start taking it before 11 a.m. because at noon it will close, and that's it. Now, obviously, the sooner you take it, the better, right? You can focus on other things, not just do this stuff all day long. So clearly the best time would be to take it on Saturday morning when you're fresh and rested and, all of that stuff. But then again, depending on your work schedules and whatever else, right, you might have to take it some other time. Topics. Well, we only covered a couple of sections. We don't have too much material here, but it's very important to know all of it, because this material is used in your courses that are after this course. Remember, this course is a non-credit course. you must take minimum one credit course to go on. So whether it's number systems, quantitative reasoning, or so forth. So yeah. All right, let's take a look at topics. So in 5.1 we learned rules of exponents. So this is where you need to know that x to the m times x to the n is x to the m plus n. X to the m divided by x to the n is equal to xm minus n. xy raised to the n is x to the n, y to the n. X to the m to the n is xm times n. Value raised to 0 is 1. Value raised to the first power is the same value. X over y raised to the n is x to the n divided by y to the n. And in general, be careful with negative 3 negative 3 squared is negative 3 times negative 3 equals positive 9, and negative 3 squared is negative 3 times 3, which is negative 9. The parentheses are not there for decoration. Have to be very careful with that stuff. Then 5.2, addition and subtraction of polynomials. So no terminology. You need to know what the term is, what leading term is, what leading coefficient is. You need to know what degree, also known as order, is. Words like monomial, binomial, trinomial, polynomial. We learned all of those words there. They are in a stream, in a lecture. You can go back and find them all if you don't know, if you missed any of them. But make sure that you know all of those words, so you know what the problem is asking you when they say factor polynomial, right? The next one is we add or subtract like terms. So that's very important. And make sure you distribute the negative when you're doing the subtraction. Then we have 5-3 multiplication of polynomials. And that's either going to be distribution or FOIL. The distribution problem would be something like 3x y minus 9, and FOIL is like x plus 2 times 3a minus b, whatever. Right, so we can have anything. So FOIL is when you multiply each one by each one, and distribution is you take this one into each. So those are the only two. And then finally, we have 5-4 special products. Where you memorize the formulas. A plus B times A minus B is A squared minus B squared. And A plus B squared is actually A plus B times A plus B. When you FOIL, you get A squared plus 2AB plus B squared. And finally, A minus B squared is A minus B, which gives you A squared minus 2AB plus B squared. So those are our special products. And there is nothing else. You either know these formulas and you apply them, or you don't know them and then you use foiling if you don't know them. Then we hit 6.1, Intro to Factoring. When you learn GCF and grouping. So GCF can pretty much be done on any type of a problem, as many terms or so on. Just needs to have needs common let's say common stuff. How about that? Because we're talking about numbers and variables or variables. And then grouping needs 4 terms, and then we can do the grouping. 6.2 factoring x squared plus bx plus c, and this is where we factor c and look for numbers. Look for numbers, or look for pair, which adds to b. 6.4 special factoring. Did this one on Tuesday, 2 days ago. This is where you have those 4 options. So over here is factoring like 1 and c and this one has the 3 formulas, the difference of squares, which was a plus b, a minus b, and then a squared plus 2ab plus b squared is giving you a plus b squared. A squared minus 2ab plus b squared is going to give you a minus b squared. And finally, a cubed plus a plus b cubed is a plus b, a minus ab, a squared minus ab plus b squared, and a cubed minus b cubed is a minus b, a squared minus ab plus b squared. Last is 6.6, solving equations. And that was the last thing we covered. To solve equations, we had that, it was a procedure, like a rule, had that rule 0 and whatever else I wrote down. So the steps were rule 0, make equal to 0. Then number 2 was factor. So that's anything that would work. Number 3 was 0 product rule, which is set each factor equal to 0. Number 4, solve all equations. Those are the simple ones, right? And number 5, win. That's the exam. That's all we have for chapters 5 and 6. It is only these, 8 sections? Yeah, 8 sections. Quizzes will start tomorrow as your practice leading into the test. Now we're going to take a look at some of the problems from exercises, from the review exercises. And again, you can rewatch this obviously to learn it. Watch lecture videos as well. And I will have another review for you guys next week on Thursday because exam would start the next day. Hopefully by that time some of you will send some questions in through whatever means, email through Canvas, or if you are on right now watching this and you have any questions, just put them in the chat and I'll answer. Otherwise, I'm just going to fly through a couple of these exercises, and you can keep watching and rewatching this until you are good with this. So, multiply ab cubed times a cubed b. Well, you add exponents, so a times a cubed is a to the fourth, and b cubed times b is b to the fourth, because 1 plus 3 is 4 and 3 plus 1 is 4. So, yeah, easy. You can have the whole expressions. A plus b squared times a plus b to the fourth. And that is also the same rule. All you do is you add exponents and you will get 6 as the exponent there. Distribution problem, where you have 3x times 4x plus x cubed would be 12x squared, because x times x is x squared, 1 plus 1, and then plus 3x to the fourth, because 1 plus 3 is the fourth. We have addition and subtraction of polynomials, something like x squared plus 3x minus 5 plus 2x squared minus 5x minus 1. Like terms, right? So we have these to be like terms. That's 3x squared. Then these guys are like terms, underlined twice. That's 3 minus 5 is negative 2x. And finally the constant at the end, negative 5 minus 1 is negative 6. So when we are adding and subtracting polynomials, we make sure to only do that with like terms. In 5.3 we have more distribution. We already seen that, but we also have multiplication. Let's take a look at two of those. Number 50 looks good. 2x minus 1 times 1 minus x. You remember that I color-coded everything. I said the first into both and then the second into both. The first one multiplied into both gives me 2x minus 2x squared. And the blue terms are negative 1 and positive x. Now your job is to, for full credit, you have to put this in the descending orders of powers and add like terms, like this one and this one are like terms. So we have to list negative 2x squared first, because that one has the highest exponent. Then we have plus 3x, because that's what we added, right, like terms. and at the end minus 1. So that was that. We can also have more than 2, and you still follow the same idea. So 4z, cross your z's so you don't confuse them with 2's. 4z minus 3, z squared minus 3z plus 1. And we again have 3 red now and 3 blue. We have the same rule where the first goes into all 3 and then the second goes into all 3. So the red terms are 4z cubed minus 12z squared plus 4z, and then minus on blue minus 3z squared. Minus and minus will give me plus, so plus 9z. And the last one is negative 3. Combine like terms. 4z cubed is on its own. We have 2 squared terms. That gives us negative 15z squared. It was negative and then we made it worse by taking away 3 more. Then we have the single z's, that's plus 13z. And finally the negative 3, which is on its own. So we can have all of that. And finally, for chapter 5, we have a couple of the special products. If you know the formulas, you can do it a little bit quicker than those who don't. But you have to know formulas for chapter 6, so just learn them, right? I mean, hopefully you'll know them for chapter 6, because in chapter 6 you have no options. But over here you do. So, x plus 3 squared. Well, this is my a, this is my b, and the formula is, I memorized it, right? A squared, so that's x squared, plus 2ab plus b squared. And that's x squared plus 6x plus 9. Let's do another example. How about 2y minus 6x squared? Again, here's my a, here's my b, and then I have a squared. Keep the sign, which is a minus. And then I have 2 times a, which is 2y, times b, which is 6x. And then finally I have plus b squared, which is 6x squared. And I just need to clean it up. 4y squared minus 24xy plus 36x squared. Problem solved. You might have x minus 6 times x plus 6, where you can FOIL, but you also should know the formula for difference of squares. And if you know the formula for difference of squares, you can just write x squared minus 36 and be done. Because the formula said a squared minus b squared. Sorry, no, the formula goes the other way for this one. A plus b, a minus b, is equal to a squared minus b squared, right? That's the formula. It's very quick. It's very quick if you know the formula. If you don't know the formula, you will still get this. It just takes longer. X times x is x squared plus 6x minus 6x minus 36. These two cancel and you get the same answer. So the idea is that you can solve the problem two ways. It's just learn the formula because you will need it for chapter 6, which is the next chapter. Now in chapter 6 we are learning 4 types of factoring. There's more, but there's going to be in intermediate algebra for those of you who go there. And for us, chapter 6 problems all say the same thing, which is factor. And then they give you stuff like 9xy plus 15yz squared. So we are going to use greatest common factor because both of these numbers have a 3 in it, and then there is a y in each of these. So if you spot common stuff, use the greatest common factor. You can immediately see that y is common. That's enough to start GCF. Now, bonus feature is that we also have a 3. So 3 times 3 times x times y plus 3 times 5 times y times z. When you write this in what I call the exploded form, it's actually factor form. We have 3's and y's that are common. So that's 3y, 3x plus 5z squared. And that's it. It's factored. There's nothing else common. You have your greatest common factor pulled in front, and these are the leftovers that go in the parentheses. Another example, a little bit harder to see, but still the same thing. When you carefully examine this, common stuff is y x plus 3. That's what's common. Each one of these has a y, each one of these has x plus 3. So that's what we pull in front. And then we have the leftovers, y plus 1. Again in blood, I know I wrote this before, but when you factor out everything, positive or negative 1 stays behind as a placeholder. What do I mean placeholder? Well, if you just factored all of this out, which is right here, and you just say, okay, so it's 0, well, it's not a 0. Because if that was a 0, then this would be written as a 0 here, and if you multiply this back, when you multiply the whole thing into 0, you're going to get a 0, not the term. So it's important to know that what stays is a 1, or positive 1, or a negative 1, depending on which sign you have. But 1 has to stay there so that when you check, right, your values have something to multiply into. It's very important. Factoring by grouping, ax plus bx minus y minus by. So you can group this in any way you want. Important thing is to see that we have 4 terms. And you factor x, right, from the first. Actually, I don't want to do that because the problem is then ruined. So ax plus bx minus ay minus by. And we put the parentheses to group, and we put the plus in between because the minus belongs to the a. What's common in the first? X. Kick it out. We're left with a plus b as a leftover. What's common for both is negative y, and you're left with a plus b. When you take a negative out, both of the numbers become positive, and you took y's out, so a plus b stays. And now you have a plus b common, and x minus y as a leftover in parentheses. So we actually had 2 separate factoring in this case. And yeah, that's it. That's factoring by grouping. Then we are moving to examples on 6.2, because I was looking at the number 5 over here, so I said, okay, so here is the example. Factor x squared plus 10x plus 24. You immediately take 24 and you put the list. You are aiming to add to 10. 1 and 24, well, that adds to 25. 2 and 12, that adds to 14. 3 and 8, that adds to 11. 4 and 6, 4 and 6 add to 10. Perfect. Done. So, x plus 4, x plus 6. Let's do another 2 examples at least. X squared minus 5x plus 8. We make the list of factors, 1 and 8. 2 and 4, and that's it. There are no more factors. No more factors. This is it. This one adds to 9. This one adds to 6. I need 5. I need negative 5. So there is no way to make negative 5. Even if I use negative 1 and negative 8 to make a positive 8, those will make negative 9, and if I use negative 2 and negative 4, they will make negative 6. There's no way to make a 5. No way to make 5. This is prime. Cannot be factored over real numbers. Can be factored in elementary algebra. Let's take a look at another example, because we can. Here's a good one. Negative 2x squared minus 4x plus 30. I'll write it again in blood. Check GCF first for every problem. So we don't know how to factor this with the negative 2 in front. Luckily, we can pull that negative 2 common factor outside, and then this one becomes just x squared plus 2x minus 15. So we need a list for negative 15, which is 1 and negative 15, 3 and negative 5. Oh, that's exactly what I need. I need negative 3 and 5. So I can have, right, because minus times a plus is minus. So, and we don't care where the minus is, on 3 or a 5, when you are doing multiplication into negative 15. But remember, it must add into a middle number. So that's how I knew that I had to switch the signs. I had to switch the signs. So this one makes negative 2. I don't need negative 2, I need positive 2 because of the middle term. These guys add to positive 2, which means these are my answers. And these are not the droids you're looking for. So, negative 2, x plus 3, x minus 3, x plus 5. Ta-da! Factored completely. And the last section and the last... Oh no! Not the last. No. We have 49x squared minus 100 to worry about. Special factoring, yes. So, 7x plus 10. 7x minus 10. Now you're going to jump. Hey, how you did it? Where's your work? There is no work. You either know the formula or you don't know the formula. There is no work. Square root of 49 is 7. Square root of x squared is x. And then square root of 100 is 10. This is in a form of difference of squares. Difference of squares is a plus b, a minus b. I know what my a and b are, and I just plug them in. That's it. There's nothing special going on here. But you need to know the formula. And once you know what your a and b are, the rest is walk in a park. Let's find one in a textbook. (36 minus y squared). Square root of 36 is 6 minus square root of y squared is y, and then you put this next one with plus. It doesn't matter whether your first or a second parenthesis has a plus, whatever. One of them has to be positive, one of them has to be negative, because they have to have opposite sign. Now, multiplication is commutative, so because it's commutative, that means you can swap the order. Where is the plus, where is the minus? The numbers are the same. So, put it somewhere. And you can do the plus and minus, or you can do minus and plus. It doesn't really matter. Now, the troublemaker problems, like x squared plus 14x plus 49, right? And that one goes square root of the first, sine of the second, square root of the third. Actually, I should have done it here. You heard me say it, then watch it a couple of times, try to memorize the words. Square root of the first, sine of the second, square root of the third, everything squared. What else? It could be tricky, like 2x cubed minus 50x. Need GCF first, because we have 2x common, and the leftover is x squared minus 25. Copy 2x, square root of the first, sine of the, well, oh, this is just a difference of squares. So square root of the first, and then minus, and then the 5, square root of the third, and then you change the sign in between. Very systematic. X squared minus 5x plus 8. We immediately recognize that we have to write factors for 8, which is 1 and 8, 2 and 4. No way to make 5. No way to make b equals 5. How about that? Negative 5. Nah. Negative 5. Alright, much better. So none of these pairs add to negative 5, even when you have the negatives there. So this is prime. Has no solution. Alright, let's see what else. And equations. Now I know I did this yesterday, and probably some of you didn't even get the chance to see it yet. Obviously the best place to be is in the class right now. You can type in the chat stuff, say hello to others and so on. So equations. We said equations have to follow those rules where you make sure everything is equal to 0 first, and then you go on with everything. So simple example is one that it's already factored, like this one. And now we use the zero product rule to set each one of these to 0. This one is already solved. This one needs plus 1. And this one needs plus 2. And I think that's it. Yep. We have our 3 solutions. We had z times z squared times z cubed, so that would convert into z cubed, and these would be the answers, solutions. Let's see what else do we have. Something a bit more annoying. Actually, x squared minus 36 equal to 0. No. Square minus 3x equal to 0. There we go. So you can see immediately on the left hand side that there is a GCF, right, greatest common factor, that you can take out, which is x, and you're left with x minus 3. So that's your factoring technique. Now, zero product rule says x is 0 and x minus 3 is 0. And add 3 to both sides. X is 0 and x is 3. Alright, one more, we'll call it a day, and then another review on Thursday. We'll do the new lecture on Monday to end the semester, so we can keep practicing for the final. So one more equation. Oh yes, t, open parenthesis, t minus 14 equals 72. Yay for the numbers, right? Alright, so remember, rule 0 says move everything to the right, to the left side. So we have t times, right, this distributes, so t times t is t squared minus 14t. And then we just have to bring our 72. Trying to see. Something is off over here. Maybe I copied the problem wrong, but I can't find the problem in the book now. Hold on. T and t. Okay, so t, negative 14 and 72. Okay, everything good. So when 3 distributes, it will be t times t is t squared. Negative 14 times t is negative 14t. And then minus, we'll put in 72. Right. So we need to factor this. And 72. So what are the factors of 72 now? Negative 72. It's going to be a very long list. So we have 1 and 72, 2 and 36, 3 and 12, 4 and 9, 5 doesn't work, 6 doesn't work, 7 doesn't, well, nothing works. Wait, no, this is not 9. It's not 9. 4 into 72 goes once. What did I do? I got all these answers wrong over here. What's going on with my computation? Divide by 3. That's going to be 2 and then 14, 24. And I'll divide by 4. Yeah, that's 24. So now 4 into 7 goes once. And then you have 32 for 18. And if you involve negative signs, yeah, okay, cool. So that all works out. We just need a negative sign on 18. Good. So we have t plus 4, t minus 18 equal to 0. So zero product rule sets each one of these to 0. And the first t is negative 4 and the other t is 18. The problem might say check, which means you're plugging these answers in the original problem, making sure they work. Meaning left is equal to the right. Believe it or not, that's our exam. We'll have another review next week. All of the homework is open for this stuff, so please make sure you are keeping current. You are practicing these things. And I will post the announcement as well, reminding everyone of quizzes for tomorrow and reminding everyone of the exam next week. Keep practicing chapters 5 and 6, and we will discuss exam 2 and possible retake or no retake. We'll deal with that at some point soon. I just need to get this exam 3 out of the way because we still have exam 4 and the final coming up eventually. So, yep, we need to do all of those things. Bye.